additional information. We'll start off with the review, L'Hopital's rule. So indeterminate form is when we have 0 over 0 or infinity over infinity. Good? What's the rule? We take the derivative.
Top and bottom.
Okay.
You're finding the limit.
Yes. So here we have limit sine x over 2x. Right? What do we want?
Well, it appears that we get the determined form when we plug in 0.
So that's going to be cosine x over 2. So if we plug in 0, we get 1/2. Right? Now, with part B, obviously we can also do this algebraically, but some people think it's easier to just do L'Hopital's rule because we'll just get 1 over 2x. 1/6. Okay, and hopefully, as you recall, sometimes we'll still end up with 0 over 0 if we do the derivative. So we just have to keep doing that until we get something not in indeterminate form. That's just the stronger form. That just means keep going, right? Just keep doing the derivative. The stronger form. That's what it's called.
We just keep on doing it. Forever.
True. So, as theta approaches pi over 2, so we'll do theta approaches pi over 2. So derivative of the numerator will be negative cosine
over 2 cosine of 2 theta.
Did you say negative?
Yeah.
Oh.
And they assume that we're going to have
We're going to have to apply
L'Hopital's
the stronger
again.
form of L'Hopital.
Right, so if we apply, here, if we plug in pi over 2, we'll get 0 over 0 again, so we have to keep going.
L'Hopital squared.
So,
Over
yeah, what do we get?
negative 4 cosine.
Sine theta?
Negative 4 cosine of 2 theta.
You don't have to.
What's wrong?
Wait, I thought you don't have to do negative because
I don't have to do negative where?
You still do because it's not your.
Bro, you're not done yet. Negative, the derivative of negative sine is negative cosine.
Yeah, but I thought
Get the reader.
you can like.
No, so like 2
there.
different functions.
You thought you could cancel it out, but you couldn't. Really.
Negative
You probably thought you could.
You're talking about here?
Yeah.
Oh, well, that's fine.
Yeah, it could just be cosine.
Well, then it would be.
But then it would just be negative sine over, but we'd have the negative in the numerator.
Oh.
Yeah.
You're still only going to have one negative,
Yeah, that's
right?
true.
So it doesn't really matter where it is, especially if we're evaluating, right? So sine of pi over 2 is 1. And what do we get in the denominator? So negative 1/4.
How hard is it to make these questions where L'Hopital has to apply?
That's not that hard. Especially with sine and cosine. If you apply one, make one without a coefficient, one with a coefficient, that's not that. Okay. If we plug in 2,
I assume we're going to get 0. Yeah. Let's just say
2.
yeah, you guys could, I mean, that doesn't take much, right? 8 here and here, minus 8. Right. Okay, so L'Hopital's rule, again, you can try to factor this, but it's much faster probably to, oops, by grouping.
I'm going to try to factor my grouping actually.
So 2x minus 4 over 3x squared minus 12. Yeah, because if we plug in 2, we're still going to end up with 0 over 0. So we do L'Hopital's run one more time, and we get 2 over 6x, which is a 6.
Curious, you cannot factor by grouping.
Yeah, I don't know where the factor by grouping would be. That we use when there's 4 terms.
Yeah, but you could make 4 terms on the bottom.
You can make 4 terms in the bottom. This is true.
That's what I was thinking, but I don't know.
I don't think it's possible.
So is it named
I'm not in the
that
mood to
Bobby
try it
Bob,
right now,
or-
so
What's cosine?
it's not really going to help us get anywhere in this point. Okay. So one-sided limits, again, this is still review. So sine x over x squared as x approaches 0 from the right. So we do L'Hopital's rule, right? So the reason we have to have a one-sided limit is there's a vertical asymptote at 0, right, with the x squared in the denominator. So we'll get cosine x over 2x.
Wait, what did you say?
Now, this is no longer in indeterminate form. This is now 1 over something approaching 0 from the right.
Which is
So
infinity.
we're not going to do L'Hopital's rule again. It's undefined, right? Or we say it's approaching infinity slash does not exist. Okay.
The limit is
So just be careful if we get 0 on the bottom and not in the numerator.
Tyler, no, this chair is broken.
No, I'm sure the chair.
Oh.
Oh yeah, it's all the chair.
Okay,
Yeah.
Tyler.
No, I'm sure if you bend it like that.
No,
it's
the chair's broken.
Okay,
Wait,
switch.
what's the
No,
derivative of
Tyler,
Really
I
happens
feel
to
like
you ever in
we're
the same
revisiting
class.
a situation from last year.
This chair is broken.
I'm sure it
Oh,
was,
wait,
my bad.
Can we put that on the
Yeah.
side with the
You don't
note?
leave so
I'm
far
sure
back.
it's not broken.
Your pocket's inside the cup.
I don't
How
care.
that happened? Put it back.
How is your
No, it's
back?
the one on the
Your
back.
How is your
What?
Tyler, please don't leave.
Okay, don't lean on the chair.
I literally just leaned back
No,
into
it's
the
exactly
back.
Okay, okay.
No, I know it's a big thing. Trust me.
All right, what do we get for this one? B is 1. Okay, great.
The limit exists for A, right? It's just,
Well, I don't think.
What's wrong?
Can you say that exists?
yeah, doesn't the limit exist for A? Like infinity is a.
Does not
it can't-
exist.
No, it doesn't exist.
And not a number.
A limit must be equal to a real number in order for it to exist.
Infinity is not an odd.
Infinity is not a real
Nice.
number. It's an idea, right? It's an end behavior.
Idea.
Oh.
I'm thinking about it right now.
Okay.
The third time.
So we have done infinity over infinity. We will now look at infinity times 0, infinity minus infinity. Now, as I just mentioned,
Keep the cursing to a minimum, please.
Yeah, please.
infinity is not a real number. It's what? It's end behavior.
It's an idea.
Okay? So
It's a movement.
that's what I put in bold here. Just remember, these are not numbers. They're descriptions of a function's behavior.
But
Okay?
infinity minus infinity is
Infinity
0.
times 0 though would be just 0, no?
No.
Anything times
That's
infinity is
exciting.
infinity.
Yeah, exactly.
Because
There's an infinite
the
zero.
first rule for one of our main rules for when we learn way back in algebra or pre-algebra, like the different rules for like multiplication and whatnot, when
So
you might have
when they
missed,
told
but
me anything
in the
from-
very beginning of an algebra book, when they say times 0, like a times 0 equals 0, a has to be a real number.
Not I.
Like,
So
I
sounds
personally
So
had to teach
a
myself
times
algebra,
0
so
equals
that's
0, but a has to be a real number. If it's not a real number, we can't assume that it's going to be 0.
like when you sound zero, when you say 0 times infinity instead of 3 times 0, it makes more sense. Like that's just too deep.
Thanks.
Like, I
But
feel like-
again, you have to remember these are not numbers.
no, I
Yeah,
know.
but in
Wait,
fourth
0
grade,
is a
you
number,
told me
look.
anything
I'm
from 0
sure the
and
classes
0
over
is
here
just
sitting on
why.
that chair.
Okay.
Does it work?
Yeah.
You're doing
No, I'm not gonna do it because I don't lean back in my chair.
Like 5 plus 3
No,
just
complex
took it, I
numbers
just kind of,
also
like,
complex
went like
numbers
that
are not
and
real
back
numbers.
Guys, could you do it
collapsed.
again? Wait.
You can't find a complex number. right
Okay.
now.
Okay, so
That one
first,
thing better.
A little bit
I
more.
got C.
so on the AP exam, we have to be able to explain why we can use L'Hopital's rule. Okay, so first thing we want to do is identify what form we're working with. So if you take the limit, so just kind of on the side here, if we do the limit of the top and the limit of the bottom,
Like 1 plus
Aren't there 7 indeterminate forms?
so we're gonna, there's more.
7.
We just, we're doing step by step.
0 to the 0.
Okay, what's the limit here?
I don't know.
1.
Okay, well, secant is 1 over cosine. Cosine of pi over 2 is 0. So that's got an asymptote. So secant has an asymptote. That's approaching a positive infinity. And tangent also has an asymptote at pi over 2. So those are both approaching infinity. Sorry. So the indeterminate form is infinity over infinity. Okay.
No.
I think I could have drawn infinity.
Trust me.
All right, so now we want to evaluate using L'Hopital's rule. So again, this is still kind of review. We haven't done any of the new forms. So derivative of secant is secant tangent.
And
Secant over sec squared.
Secant squared.
so sec.
And then you get tangent over secant, which is tangent.
Oh, and I just realized, sorry guys, that should be a limit as we approach pi over 2 from the left because of the asymptote. Sorry, there was a little negative sign missing there. Okay, so I'm just going to rewrite this. What's happening to our secant?
Oh, we do it again? Oh no, you're rewriting it. How could we cancel out? Oh wow, that's smart.
Can we rewrite tangent
As
over
sin x over
secant?
cosine x
That's
squared.
just going to be sine x, right?
Wait,
Wow.
what?
That's like,
Yeah.
it's like chapter 5 of pre-calc.
Oh.
I do
Okay.
not remember why.
Okay, sine over cosine, and this will be 1 over cosine. So what's going to happen?
Cancel out.
So we just get sine, right? So limit as x approaches pi over 2 from the left of sine x will be 1. Good. Why would I not want to do L'Hopital's rule again?
It would be helpful, essentially.
Well,
Because this you'd have
I'm
to
just going to
simplify.
just keep getting secant squared over secant x tangent x,
It's weird. Why did they
right?
do that?
And then it just keeps going. So eventually, if we can simplify it with trig identities, that's what we want to do. Okay, let's see. What indeterminate form do we have here? Yeah, I'm just going to write. So this is going to be infinity over infinity. Again, I don't want to take the time to write it all out, but you know on the AP exam you have to write out the limit of the top, the limit of the bottom. Okay, so in the numerator we have 1 over x. In the denominator, we're going to have 1/2 x to the negative 1/2. The 2's and the 1/2's going to cancel. So it's just going to be 1 over root x.
Put 0 for this.
Yeah, I got 0.
Yeah, because essentially what do we end up with?
1 over
X.
2
One-
Root x over x. And that's just approaches to 0.
Root x over x, which would just be 1 over root x.
Yes.
Well,
Can you make any
Or you
function?
can just do the power, like
I
the
just know that
highest
x over root x
degree
is-
rule.
The root
oh,
x
yeah,
over
yeah, yeah. Well, root x over x would be an x to the 1/2 over an x to the first, which would just be an x to the 1/2. Yeah, you could do the degree of the top, degree of the bottom. I just figured to simplify it, then you could just see the denominator is
I think I
going
did
to
it
be.
wrong, but
But then couldn't you just take any function out of indeterminate
I got
form
1
by
over x
multiplying
squared.
by the either the top or the bottom?
Can we what?
Couldn't you just
Zero.
take any
Yeah. I think it
function out of
root x.
indeterminate form by
It's into the
multiplying
top,
top and bottom by like
bottom.
natural log of x or something? Or dividing top and bottom by natural log of x?
You get that answer.
No, because if it's infinity over infinity, infinity times something is.
Wait, let me work this out, Matt.
Okay, you work that out. I'm going to go to the next one, which is in the form of infinity times 0. Again, this is,
He's kind of a goofball.
so we want to, again, just remember, these are limits, not real numbers. So what we want to do is we want to somehow manipulate this expression inside so that we have it in infinity over infinity or 0 over 0 form. Okay, so that's going to be the goal of the rest of the lesson, is anytime it's not in 0 over 0 or infinity over infinity, we want to rewrite it.
So what, like x over cosecant?
Okay, so there's more than one right answer. It's going to be.
Yeah, I think I'm gonna also do x over this.
Or you could do sine of 1 over x over x.
Okay, I'm going to, so more than one way to do this. I'm going to leave sine of 1 over x. And I am going to change this to 1 over x in the denominator. Okay? So first, make sure we agree those are equivalent. Right? Multiplying by x is the same as dividing by 1 over x. Now, what have I done in this process? I've made it 0 over 0. Okay? Now that it's in the 0 over 0 form, right? Now I can do L'Hopital's rule. Oops, let me just put a.
So you just get cosine of 1 over x, which is 1.
Okay, hold, slow down there.
Wait,
Yo,
so
can you just
0
take a
over
breather
1
maybe?
over 0.
So it's going to be cosine 1 over x times negative 1 over x squared over negative 1 over x squared. How convenient.
What gum?
Right? Because 1 over x is x to the negative 1, so it would be negative 1, x to the negative 2. How beautiful is that? Wow, right?
You get more instruction paper so you can spit it out.
And so now that makes it cosine. Hey, Tom. Adam,
He's
go
so
outside.
annoying.
We're going to be
He's
disrupted.
so annoying.
Cosine of 1, or sorry, cosine of 0 is 1. Okay, so
Very minty, right?
here we have an example where we took something that the behavior of the graph was infinity times 0. We got 1.
One.
Pretty
Not
nice.
bad.
Okay, what indeterminate form do we have in this example? So
0.
1 over 0
1 over
minus
0.
0
1
minus
zero.
0.
okay, so
infinity minus infinity.
infinity minus infinity.
Yes.
Okay, so before we do L'Hopital's rule, we want to rewrite this so it's 0 over 0 or infinity over infinity and behavior. Any ideas?
X minus 1 minus ln x.
Okay, so find
We
a
can
common
make a common
denominator.
denominator.
Let's try to combine these
Wait,
two
thank you.
expressions.
I think that's a better way to do it.
See, did you get it with 1 over cosecant?
I got
No,
it.
I just did the way she did it. That seemed a lot easier.
Again, there are multiple ways that you could approach these problems. Again, it all has to do with algebra. It's all just
So I got-
algebraic manipulation before we do L'Hopital's.
I got like 0 over 0 times 0, so I think that's
0 over 0 times 0.
I think that's like 0.
No, it's a 1.
Yeah, as it approaches 1, but what is ln of 1 times 1 minus 1? 0 times 0. Next time back.
Wait, can you just change the ln to negative ln of x? I thought that would be easier.
Definition.
Okay, what format is this one in?
0 over 0.
This one is in the format of 0 over 0. Okay, so now I want to do L'Hopital's rule. Okay, in the numerator, we're just going to get 1 minus 1 over x.
Yeah, the denominator is.
Okay, denominator, we're going to have to do the product rule. So we'll have 1 over x times x minus 1 plus natural log of x.
It's pretty fun.
I'm glad you said that.
All right, what do we?
I'm getting 0 over 0.
0 over 0 again? Okay. Now, we could do L'Hopital's rule again, or we could try to simplify this algebraically. I'm going to try to simplify it algebraically because I think that might be an easier approach. But again, performing L'Hopital's rule isn't wrong. I'm just trying to figure out which one is going to be easier.
Yeah, because I feel like you kind of knew that.
Well, then
Wait,
you have
what's
to do
what's the
another
derivative of
product
x
rule.
ln of
Did
x?
you have a week?
Yeah, you'd have to do another product rule, which is why I would try to eliminate this algebraically. So let's, I'm going to multiply just the top and the bottom by x. So let's see what happens. That's going to make it x minus 1 over.
You don't necessarily have to do another product rule if you distribute it.
What's that?
If you distributed it, you don't have to do another product rule. It's just 1 minus 1 over x plus ln x. From the denominator.
Wait, derivative of ln x is 1 over x.
Yeah, you could do that. You could do that.
Okay, so derivative of ln x is just 1 over x.
Yeah.
No, the derivative, it's not just 1. The answer should be a half.
If I plug in 1.
Yeah. So again, this is not the only way to do it. So like Jonathan, you said you can distribute it. Fine.
If I put in one, I
That's
get-
fine.
I get two.
You can distribute it.
So now
That's
we
fine.
L'Hopital's it from here.
Yeah, and so right away I know by doing L'Hopital's rule this second time, I'm gonna get 1 in the numerator. So I know I'm done anyway. It just is a matter of let's see what happens in the.
Can you not cancel out the 2x minus 1s?
No.
Oh, they're separate.
Oh, that makes me
Never
sad,
mind.
Harrison.
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 That's my fault.
There's this plus sign.
I know.
Okay, it's all right. It's all right. We'll forgive you this time.
Oh, that.
So this is going to be 1 plus natural log of x plus x times 1 over x, or just plus 1. So that's going to make it 2 in the denominator, 1/2.
Oh my god, that's really cool, Miss Casey.
I think so.
I like it a lot.
Okay.
And now you're gonna tell us.
So again, we took something that was in the form infinity minus infinity. We got a half. Pretty cool.
I don't think we're gonna be home in time, but that's still be fine.
So here's the thing. We have 2 days for this lesson. If we finish it, then we can spend. We could either pause here, or we could just keep going, and then the next class we could just use it for homework time.
I think next class is just
Or
Yes, next
could we
class.
do
Our
a
next
review
class.
day?
We have a review day, yeah, because I don't have one. I want to have a review day before the quiz this time.
Yeah, so could we do a
Do you have one of
review
the
day
books?
instead of
Have a
a
quiz?
homework?
Yeah.
How about we do both?
Okay, next format.
I don't know.
Okay, so Jonathan was asking, aren't there more? Yes, there are. Okay, so here's some more indeterminate forms. 1 to the infinity, 0 to the 0, infinity to the 0.
Why is 1 to the infinity indeterminate? Isn't any one anything?
No, because infinity is just end behavior.
Okay,
It's negative,
again,
it's not a number.
infinity is not a real number.
Does it matter?
If it's negative,
So 1 to any real number.
Is
So if A is a real number, then that's 1.
So then what?
But is infinity a real number?
It's just a big number.
It's just 1 times 1 times
Does
1
that
times
be-
1 times 1 times 1
And-
infinity times.
Does that
But then
What
it
are
makes
we
equal-
looking at? Everything is in depending on
Actually, it'd be
limits.
1.2.
See, this is where it gets kind of like more
If it's a-
theoretical,
if it's
right?
a-
Any
Limit
number
as
of
x
a
goes
Doesn't
to
it
infinity
still
of
just
1 to
apply
x,
to
you get
one?
1.2.
Okay, so these limits are going to be found by, we're going to end up doing logarithmic differentiation. Okay, so we did some of this last year in AB. So what we're going to do is we're going to take the natural log, and then in the end, whatever we get, we're going to have e to that power, right? Because we're kind of taking it apart. So for example, first let's identify the indeterminate form. This is going to be 1 to the infinity power.
Can it be any number to the infinity or only 1?
Like 2 to the infinity?
Yeah,
I'm
like
sure
2
that
to
would be infinity.
Well, 2 to the infinity would still be like a form of
Does not.
indeterminate, yeah.
Wait,
Indetermination.
as you approach infinity, doesn't 1 to the infinity still stay as
1.
1?
As you like limit as x approaches infinity of 1 to the x.
Like it's still gonna be 1. There's no number that's not gonna make it
Right. That's why I said 2 to the infinity is still going to, right?
1. No, but for 1.
For 1, what
1
about
to the
it? 1 to the infinity?
infinity. Yeah. Isn't it always gonna be approaching 1?
No, look at A.
No.
Well, like
I
what?
understand that it only works with real numbers.
Okay.
But
So I will tell you, this example is not approaching one.
That's E.
In fact, does
that's
anybody,
E.
you see it's E?
That's E.
Now we'll prove it.
That's E.
Do you remember the 1 plus 1 over x to the x power? That's our definition for E as x approaches infinity.
But it's infinitely.
So let's prove it.
Where you got a lot.
We do not remember that. This is our. That's how we define E.
I think you're having a Groundhog Day situation.
No, bro, that's E.
Okay, so here, this is what we're gonna do. We're gonna let's just let 1 plus 1 over x to the x power equal to 1. Okay? So we'll kind of just make an equation for now, so that you can see. What we want to do is we want to take the natural log of both sides. So this is where our logarithmic differentiation comes in. So we're going to take natural log, which allows us, because when we have a base and an exponent that have a variable in, we want to get that variable out of the exponent. So we'll put the x in front. Okay.
And
Now what?
We
Okay, so I want to take, so,
EY.
well, first thing, I'm just going to throw that limit back in.
And then you get
Okay, so this, on the right side, this is what we want to evaluate. And then just remember y is equal to that. So when we change it back to exponential form.
But we're deriving first, right?
Yeah. What, in other words, we should get this is equal to 1. Right? Because natural log of y would equal 1, which would then mean
Well,
the
natural log
limit
of y
is
equal-
approaching e.
I said natural log.
Okay, so let's rewrite this first. What form is this in? This is in the form of infinity times 0.
the derivative of the inside.
So we want to rewrite this so that it's 0 over 0 or infinity over
We don't derive first. We don't just derive right there.
No. When we do the when I say logarithm, like we're moving the logarithm,
The
and
X.
then we're gonna do this part.
So
X
just
goes to the bottom. So
Yeah, we're gonna make this 1 over x in the denominator.
And then the derivative of the inside cancels out the bottom. So it's just
Yeah,
whatever-
sorry, I probably should have left you guys more room. I'm gonna just go up here. So my L'Hopital's rule is gonna be,
ln of y equals 1
so it's
over
gonna be
1
1 over 1 plus 1 over x times negative 1 over x squared over negative 1 over, x squared. Which again works out beautifully.
No, I'm kidding.
Which means I should get what I wanted, which was 1. So remember, if natural log of y was equal to 1, then that means y has to be e. Therefore, my limit as x approaches infinity of 1 plus 1 over x to the x power is equal to e. Yeah.
How do they figure this out for the first time?
I don't know.
'Cause I feel like you can only use it by knowing that ln of 1 equals e, and you can only know that ln is anything when you find e.
What did they find out
My math
first? ln?
teacher, he would say they had a lot of
What-
time back.
You can look.
Oh, the one right here.
Yeah, I guess it's revised.
All right, what
I
form
think
do
it's
we
more
have? We'll do one more, I think.
X to the
X to the
infinity
0.
To the 0.
Oh, okay. Infinity to the 0.
Which is
Okay,
Which
so
I guess is not determinable. Currently. Apparently it's not
Well, just
determinable.
determine what it is.
I want it to
That's
be
just
one.
I
correct.
I could probably figure it out, to be honest.
Adam,
But, yeah, I mean, kinda. You could totally let that equal 1. If we why don't we just say let infinity to 0 equal 1?
you just do ln x over x.
Shut up. These are limits. Limits are like, imagine if it's like if a
yeah, yeah. So here, if we just want to make this natural log of x over x, that'll just make it infinity over infinity. This one's actually easier than the last one
You just see that
because
x approaches infinity before
we don't
ln
have to
x.
do any manipulation really here. So L'Hopital's rule will say
It's just 1 over x.
there's just 1 over x, right? Which goes to
0.
0. So,
0 is 1.
so natural. Oops.
Will I ever get like 6 or like 7 for one of these or something like that? Will I always get like E or 0 or infinity?
If there's like a constant.
Yeah, if there's a constant somewhere, you could. So what's y equal to? 1. So therefore, the limit as x approaches infinity of x.
I like how we have a problem with nothing to do with y and we solve for y.
Well, we had to introduce
You gotta create a Y.
We create a y and then
Yeah.
assign a value to it.
It's like a function.
Arbitrary.
I guess we could do it now.
Funko.
Why not?
Oh, this is the goal
For all of these.
to make it in the term in form of infinity over infinity or 0 over 0.
Yeah.
These
Such
are
so
funny.
that-
That's because we cannot.
I
If you go back to the very first definition for our L'Hopital's rule, the only time we can do L'Hopital's rule is if it's 0 over 0, infinity over infinity. So if it's in a different form, we just want to do some algebraic manipulation to get it in that form.
Did we get one?
So this one, wait, did we get 1 for this one?
No,
No, I got 1 for this
for
one.
B.
Oh, for B, yeah. This one is in the form of 0 to the 0.
Equals 1.
Which that's somehow not.
0 to 0 is 1.
Okay, again, so you're saying 0 to the 0 is 1.
I could say that.
You could say
Well,
that.
then where
In
does
this case, what's 0 over 0? What do you think about that?
It depends. But this is 1.
You think this is 1.
No. I'm pretty sure this is 1.
I'm pretty
Anything
sure
to
it's
the
1
zero
also.
is
But
fine.
Adam,
Anything
let's
to the 0 is
use
1.
the
But
calc
why?
to check this.
I know it's 1.
Because I solved
Why is anything to the 0 1? That's just because
Adam, it's undefined actually.
Yeah, because your calc does not do 0.
Well, yeah, 0
My
to
calc
0.
doesn't do 0.
0 to the power of 0 is undefined.
Is your calc not?
Wait, what?
Oh, wait, I didn't mean limit. Sorry, I didn't mean the limit. I meant to put natural log. Sorry. Jumping ahead here.
What ln means? It's a natural log. Why? What is it's log with the base of 10?
No.
0? No, close.
That's 10.
No, that's just log. That's just rewrite the log. Oh. What is it? E. Oh, right.
Oh, I don't know why I put the X in front. Boy, I'm really messing up here. I'm trying to skip steps and
In
I'm.
college, you do not have to. You just have to do normal.
Sometimes you have to do it. Palmer's texting with all his calc questions. He's saying calc? Yeah. What is Cooper taking? What is Cooper taking? I don't know. Taking money laundering. That was a good one.
Or investment banker. Like the classic Jew. You know my cousin who's 10 years old wants to be.
Wait, you don't
investment
get 0.
Was he
0
born
for
in Brooklyn?
banker. Oh, shit.
So I'm going to write this as natural log of X over 1 over X.
That's a classic trick. I'm gonna start
And then
using
you
that.
get 1 over x divided by
Classic
1 over
case of
x squared.
So now what do we.
Negative x.
1 over X over negative 1 over X squared, which is just
Negative x.
negative X.
Which is 0.
No way we get 0 for this. This case of
Yeah, but then natural log of y is equal to 0. So what's y equal to? 1.
okay.
So therefore, the limit as x approaches 0 from the right of x over x approaches
In
1.
this case of, let's say we did this limit from the left.
Why would you do
Yeah,
Would
how
we
would
get
you
a 1
do that?
still? Would we still get 1?
Probably.
Like, how do we account for the fact that we're taking it from
Oh,
the
is
right?
it because there's an asymptote you have
Adam,
to
this
do
is
it?
gonna be
No, I don't
so
think it
bad
is.
to do on
Yeah.
a test.
I don't think it is.
On the test, I'm gonna be like, because if that said limit as x approaches 0 from the left, I would have no way of telling it apart from left to right unless I plugged it in my
So
Same.
on the test, could I just say 1 because it was 0?
Yeah, I don't think it would be 1 because then you get a negative inside a radical
It is.
Because then you got a negative.
from the.
I read. Plus
actually sounded like a
I haven't thought about it.
it.
Do I need to think about it? No, thanks, Aaron.
This is. Why did we go from a super easy lesson one to existential theoretical possibilities in lesson two?
Okay, but let's think about it, really.
It's like
Other than just moving some things around, it's not
it's like
all
Oppenheimer
of
going
math
from
is
throwing a
moving
water
something.
balloon to
Move
dropping
around.
it.
You know,
This
it's
isn't
calculus
bad.
hard, it's actually the algebra that's harder. You know, that's always the algebra that gets you.
This is theoretical.
It's like not even real stuff that we're working with right now.
My
This will never describe a real
I
life.
don't think
What
I
was
should
the
always
answer to
single
the one
use
above?
glue that
Bob
much.
The answer was 1.
This function will never describe real life.
Bob has limit as x equals to infinity of ln of 1 over x apples.
Wait, I have a question.
Yeah, go for it.
Yeah.
What does this get you in life? This gets you.
No, I have a genuine question. What does AP Calc BC do?
It gets me out of taking Calc BC.
And also, I don't have to. It gets me to not
You'll
have to
still
take
probably
pre-calc with Leon.
Yeah.
Think about that.
That's really cool.
You need a lot of this stuff each on in science.
Do you
Okay,
want
so
to
you-
major in
Yeah, that's true,
Are
actually.
you using what?
I want to major in political science, but if I'm ever like a politician and they ask me this stuff, I need to sound smart.
Yeah, if you're ever, this is insurance, just in case a mathematician ever puts you on the spot.
I'm doing the debate and I'm like, oh yeah, what's the limit of x over x?
Still
Yeah,
one.
Tyler,
This is
wait,
my-
Wait,
can you
doesn't
find
ln of ln x
x
cancel out?
to the power of x
Really
is
what my
equal to 0, right?
calculus
But
education
I
is
get it
for,
right
so
now,
that
the
when
text is
someone
kind
at
of
Berkeley makes a joke on game day and my mom needs me to read the sign in calculus, I can. And then I can.
I want to go to Stanford. What do you think about that, River?
Probably.
I mean, you can
Probably
spend
only
an
one
outrageous
reason.
amount of
Oh,
money
what are you
for the
taking
same
next?
Okay.
education as Calc if you want.
Here, this one's
Never
pretty
call it Calc
straightforward.
my favorite. Never call it Calc.
One over
Every
x
one
times-
semester
so we get
was-
0.
I hate when people
Yeah,
call
I'm
it
not trying to.
Ooh, ow.
It was the original.
Ooh, we were
What
first.
are you gonna do instead?
I do
You're a
it.
senior.
They call it Berkeley. There are other Cal schools now.
Wait, don't we have to
Famous, case of
don't we have
Why
to
is
do
it
the y
percent
part?
Cal?
Sure. Sorry, I was skipping a step.
Whenever someone says Cal, I think Cal.
Yeah.
Whenever Rachel Stallings says Cal,